Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor Space. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It'll run for approximately 1 hour with time for questions throughout. I will now turn it over to our speaker for introductions.
Hi, good morning. My name is Maraki, and I'm so excited to tell you a little bit about open mirroring and the amazing work that we've been doing around that. I'm joined by a special guest from one of our amazing partners, Striim, who has done an amazing integration with open mirroring, but more on that in a little bit. So to kick things off, I really want to spend some time first talking a little bit about Microsoft Fabric, the unified data platform for all AI transformation. Now, every person within your organization, regardless of their skill set, has a need for data and AI to drive business insights. And Microsoft is the one-stop platform to allow all your users to be successful with data and AI, whether they're business users, data engineers, data scientists, whether they're users that are trying to, take advantage of the real-time intelligence to drive business value. Microsoft Fabric is the AI-powered solution that is built on a foundation called OneLake that we'll talk about in a little bit, that allows your organization to be successful on one single unified data platform for AI and data and for AI transformation. So what exactly is Data Factory? Because that's where we're going to spend a lot of our time today. Data Factory essentially combines the data engineering capabilities that require you to build data pipelines through platforms like Azure Data Factory, Synapse Link, etc., with some of the more self-service data preparation tools that are for some of these more citizen users who are coming from Excel, Power BI, etc., and brings it all into Microsoft Fabric, an integrated SaaS platform that allows you to use code or no-code tools for all of your data integration needs. As with everything in Microsoft Fabric, it's Copilot and AI powered, as well as has a lot of really amazing open source solutions as well. So the components of Data Factory, more specifically, start with kind of on the left-hand side, best in class connectivity, best in the industry with 150 plus connectors that you can leverage today to build your pipelines, build your transformations, and start orchestrating your data and managing your data in a way that makes sense, right? But once you've been able to actually connect and build your pipelines, you have to be able to deploy your data effectively. You have to be able to observe data quality issues as they come up. Data Factory, like everything else within Microsoft Fabric, is built on a foundation called OneLake, right? Which is our unified data lake for all of your data storage needs, and powered by AI with all of the amazing Copilot capabilities that we have built in. So what are the different components that make up Data Factory? So there's pipelines that allows you to ingest data at scale and schedule data flows. So if you are a data engineer that needs to manage flows and pipelines allow you to do that. Data Flow Gen 2 allows you to prep, clean, and transform data in a really great way. We have Mirror Database, which allows you to easily replicate data from an existing source into OneLake. Copy Job, which essentially does what it suggests. It helps you copy data easily with settings for full incremental or even event-based refreshes. We also have integrations with Apache Airflow, right? Microsoft Fabric is not just allowing you to use Microsoft-built tools. It allows you to use a lot of these open source technologies like Apache Airflow in a really effective way. And if you're a customer that's already leveraging Azure Data Factory, you can actually link ADF into Fabric and be able to use all your ADF pipelines in Fabric, which is super amazing. So today's discussion is going to be purely focused on Mirror database, but it's really important to kind of understand all of the landscape of what makes up our data integration capabilities within Microsoft Fabric before we delve a little deeper into mirroring specifically. So what is mirroring exactly? In order to understand what mirroring is, we actually have to spend some time talking a little bit about OneLake for data. So OneLake is sort of like OneDrive for data. That is the analogy that we use to explain it to a lot of our customers. It is our unified data lake for all of your data needs that allows you to store your structured data, your unstructured data, and it's the foundational layer that Microsoft Fabric is built upon. It allows you to leverage this data lake as a service without needing to build it yourself, which is really incredible. You don't have to deploy a data lake. You don't have to deploy, all of these different types of resources in order to leverage it. You don't have to manage. You just kind of set it in one place and you're ready to go. So now that we kind of understand OneLake, what we allow you to do, right, is ingest data into OneLake, leveraging one of a couple ways, right? OneLake is the first multi-cloud SaaS data lake, like I mentioned earlier. And we have shortcuts today for existing data across clouds and on premises. So this is super effective for your unstructured data, your multimedia data, your data around social media, comments, tweets, etc., things like that. Now, mirroring, on the other hand, allows you to add whole databases into OneLake and unify your data estate in that way. So if you have data sitting in Snowflake, if you have data sitting in Azure SQL DB, if you have data sitting in a CSV, right? You can leverage mirroring to unify all of that data into OneLake so your organization can access it in a single unified platform, Microsoft Fabric. So mirroring in Fabric is essentially a reflection of the external database into OneLake. It ensures that the entire database shows up in OneLake and reflects all changes in schema and data changes as they come in, because we have a built-in CDC capability that replicates for proprietary formats, but also allows you to automatically maintain and set of shortcuts to the external database for open data formats. So that's just kind of the overview of how mirroring works today. So mirroring essentially takes data from your source DB, lands it into the landing zone, and then we leverage CDC processes to convert it into tables in OneLake. Now, setting up a mirror is super trivial. The mirror data itself is automatically kept up to date in near real time. And the beauty of it is once your data is in OneLake, mirroring is actually free. So there's only to gain from leveraging mirroring for all of your data unification needs. So today, mirroring as a whole is available for Snowflake and Azure SQL DB. And we also have in public preview support for Cosmos DB, Azure SQL MI, as well as mirrored Azure Databricks catalog. With a lot of other capabilities that are coming soon. We also are working on lots of really amazing capabilities to enable public REST APIs for database mirroring, supporting sources behind a firewall. So if you want to leverage VNet Gateway or OPDG, you'll be able to do that soon. We're also working on ALM support and deployment pipelines, as well as Git integration and monitoring improvements so that you're able to leverage this capability at scale and get the insights that you need on demand. But with a lot of the capabilities that we've been building for mirroring, right, a lot of our customers have told us a couple things. One customer has told us, hey, my data resides in databases, but it's not yet supported by database mirroring, right? It's not a Snowflake source. It's not sitting in Azure SQL DB, et cetera. Other customers have told us that they want an efficient way to help manage the complexity of merging and updating Delta and Fabric. And then lastly, right, Customers want to be able to leverage existing data tools and have control to write into Fabric themselves. And so that's where open mirroring comes into play. Open mirroring is a new capability that's currently in public preview. We're super excited about it, that allows applications to integrate data into OneLake via mirroring. So you as a customer can build your own open mirroring app and start ingesting data into a MirrorDB. But we also have partners like Striim that have built sources that allow you to leverage those sources to drive data into OneLake. So open mirroring enables landing data via APIs or manually via drag and drop UX, as you'll see in a little bit. And it simplifies building custom mirroring solutions and handling the complex data changes, ensuring that all mirror data is continuously up to date and ready for analysis. So this essentially gives you and empowers you with the capabilities that you need to get the data that you need into Fabric, especially if those capabilities are not supported by our core mirroring capabilities today. So here's a quick demo of how mirroring works for Parquet.
Starting right from my Fabric homepage, I'll create a new item. Here, I can see all of my data sources: SQL Database, Cosmos DB, and Databricks in preview, and Snowflake generally available. And soon you will see our two new sources, SQL Server and PostgreSQL. But now we have a powerful new option, and that is Mirror Database, our open mirroring functionality. Let's go ahead and click and select New Mirror Database. From there, we'll give it a name and hit Create. Now, let's go ahead and show some of the inside mechanics of how open mirroring will work. I have some orders data saved as a CSV file on my desktop. If I go to my folder and I open it, you'll see the rows and the headers. All I have to do is drag and drop it into the landing zone, and the file immediately shows up. Our engine immediately writes initial snapshot and change data, processing it into an analytics-ready format. And just like that, within seconds, my tables appear in OneLake on the other side. A table was generated from the CSV file. I can either go to the replication status to monitor my rows, or I can go to my SQL Analytics endpoint. Let's head to my SQL Analytics endpoint and verify that my rows have been replicated over. Right now, I'm working with around 62 rows of orders data. But as we all know, new orders are constantly being modified or created either through Python scripts or manual updates. I want to ensure every change is reflected. For example, zooming into the first row here, I notice that the order price for this row is wrong, and I need to change this price to $100,000. All I need to do is create more CSV files with only the changes. For this particular row, I have a CSV file that has an upsert. And see, the difference in these CSV files is that it's got a column here that tells us the operation of each row, like insert, update, or delete. I have gone ahead and updated the price to $100,000 for this particular row. But look, I can add even more operations in the same CSV file. In this case, I'm deleting 3 rows. And you can tell that by seeing that the row markers are marked by 2. That corresponds to deleting the next 3 rows from my orders table. And lastly, in that same CSV file, I am inserting 5 rows with the row marker as 1, letting the engine know that 5 brand new rows will be added to my orders table as well. I could have separated all these operations into different CSV files or packed them into the same one like I have done here. Let's navigate back to the landing zone and drag and drop the CSV file here, and the file in the analytics ready format automatically shows up. And now look, the table in OneLake just got updated with these instructions. I can quickly go to my SQL Analytics endpoint and verify that all my operations have been done. The first row has indeed been updated with the correct pricing number. I can also verify that the 3 rows that I have deleted are no longer showing up here as well. And lastly, I can confirm that my 5 rows that I added at the end of my CSV file have indeed been added in here as well.
Awesome. So this is how mirroring works, and this open mirroring works from a user experience standpoint. You saw it today for CSV. That will be available soon. And we are super excited about it. Today we have several open mirroring partners that we're really excited about, and we're growing this ecosystem to help streamline delivery of mirroring solutions in Fabric. So we have a solution from Oracle Golden Gate, solutions from MongoDB, and other partners that we're currently working on. But today, we're going to talk more specifically about Striim and the integration that they've built using our open mirroring API. So with that, I would love to introduce Codin, who is the Vice President of Partnerships at Striim. Codin, please go ahead.
Thank you, Meraki. Nice to be here. If we can jump into the next slide, Meraki, I can get started here. So Striim is a data integration company focused on real-time specifically, and even more specifically, a major focus around log-based change data capture from databases. Our previous company was a company, Golden Gate Software, which was purchased by Oracle. You actually happen to see it on Meraki's previous slide as one of the partners involved with open mirroring. So we sold that company to Oracle in 2009, and then in 2012 got back together again and built a brand new company with the idea of taking all the lessons we had learned from our customers and our many enterprise customers, and basically coming up with a brand new platform to enable that. So basically there were several concepts. The reason I'm giving a little bit of a historical context is so that you understand where we're coming from and what our entire approach is when it comes to data integration, since there are many vendors with different approaches, different focuses. So I think it's healthy to understand a little bit about where we derive from. So I mentioned Golden Gate as our background. I worked there in engineering. It was my first job out of college. So we're all database guys originally. And basically our whole thing was how do you move data in real time from a variety of different sources and connect them to analytics, connect them to other operational systems. How do you keep these data sources and targets in sync continuously 24/7 without any sort of issues, without the losing data, with exactly one's processing semantics. So the key technology involved, and for perhaps everyone here already knows, but just in case, is when you want to turn any database into a continuous data source, just doing a bunch of selects would have a big performance hit. So if you have like an important e-commerce application running on top of your, let's say, Oracle database, and you want to select against it multiple times, it's going to be very complicated. It's going to hit your performance. Your overall application will suffer. So then the trick is every database typically has recovery logs. So as soon as a transaction is committed, transaction gets written ultimately to underlying log files. So then what you can do is you can pretty much listen to those log files, sniff those log files, if you will, and capture the changes as they occur. So inserts, updates, deletes, DDL changes like alter, table, drop, column, whatever it may be. All these changes are coming through, and we're capturing both a DML and DDL, and then moving it with sub-second latency into a variety of different targets. So that's the log-based change to capture concept. That's a real-time aspect. Additionally, when we started Striim, as I mentioned at Golden Gate, we had a lot of enterprise customers, and a lot of those customers were asking us for additional capabilities, not just database to database, but database to analytics. Also, this was the advent of cloud, so there's a desire to tie all the data together. So long story short, we ended up creating a brand new platform which does multiple things. Number one is we can ingest from a variety of different sources, whether that be Oracle, SQL Server, MySQL, DB2 mainframe, Mongo. We also support things like applications like Salesforce, HubSpot, etc., because some of our customers have asked us over time to add those capabilities. We can ingest from IoT, MQTT, OPC-UA, log files, Kafka, messaging queues, etc. So ability to ingest from all these different sources, move that data in real time with sub-second latency into the cloud, in this case into Azure. And you can see here that we support all the different targets in Azure, whether it be Cosmos or whether it be Fabric. And obviously today's focus is talking about Fabric and mirroring more specifically. But we can ingest the data, deliver it to all these different targets in Azure, whether it be Databricks, and we can deliver it to one or multiple sources, multiple targets simultaneously. Additionally, the data as it moves from point A to point B can be transformed within Striim. So we basically have the ability to write SQL on the pipelines themselves. So as the data is flowing from point A to point B, you can aggregate the data, enrich it, denormalize it, mask it, We have things such as automatic PII identification and tagging using our own built-in AI algorithms to accomplish that. We can create vector embeddings of your data on the fly and then update your target system with those embeddings so that you can have the necessary embeddings in order to implement your RAG use cases, prompt engineering, etc. And so additionally, I should mention here is that when I'm talking about real time, I'm talking about sub-second latency. So for example, one of our customers during Black Friday, you can tell it's a retailer, they had, I believe, 200 milliseconds of lag between the source and target during the busiest time of the year. So that's the kind of real time that I'm talking about here. We're deployed in Azure, so we run as a SaaS. You can also install Striim on a VM, so we have a self-managed version of it as well. That's useful for certain customers where you have very tight InfoSec requirements, and sometimes it's easier to just get started with that because then the data just resides completely within your system. You control it, and it's a lot easier to get through those requirements. But a lot of customers obviously prefer the fully managed SaaS version. And I think on that note, Maraki, can we go to the next slide? So what I should mention here is we've been working with Microsoft for quite a number of years. We have a strong relationship. On one of the previous slides, you saw Satya highlights Striim as one of the key partners. We've been working closely with all the different teams, ranging from the database teams, like the Azure Postgres teams, SQL, etc., but also working very closely with the Fabric teams, ADF teams, etc. So, and this is a good time to mention. So Maraki mentioned and was talking obviously about ADF, and so oftentimes we get asked by customers, it seems like there's you guys do similar things as ADF, so how does that fit? And so what it is, and what I always like to mention, and this is something that I think resonates well, is that we are complementary. So there's a lot of different sources and a lot of different systems that you can connect using ADF. And for those workloads, you're set. However, and the reason we are working so closely with Maraki and team is because of the fact that we support all these additional sources that are currently not supported within ADF. And also the other key differentiators, we really focus on real time. So, if you have more of a batch, that's something that you can do within Striim, but really our focus is on the real-time aspect. So high volume, high velocity, very tight SLAs, and then all the different sources that we support. And therefore, this is why we're partnered, so that we can help customers get access to these sources as they're perhaps being added over time to ADF's own capabilities. So specifically around open mirroring. So we've been working with the Fabric team for quite some time. We have a variety of different ways to deliver data into Fabric, but additionally now with the open mirroring capabilities that were recently added by Microsoft, we realized that, hey, we can also start moving some of the sources that we support. We can take advantage of those mirroring APIs and deliver the data through those mirroring APIs. The key advantage ultimately to customers, because we can deliver that data directly as well. But one of the advantages is the cost factor. So by utilizing these APIs, customers can take advantage of that free cost when it comes to the storage part of the data. There is a cost associated with Striim, but it's a low cost version. Striim itself, would have a higher cost, but we've specifically created a very low cost version of Striim for mirroring to basically encourage customers to be able to move their data into Fabric as easily as possible and with as less friction as possible. So Maraki, maybe we can go to the next slide. So what I wanted to highlight here is all the different approaches. So as I said, historically, we were always able to deliver data into Fabric. We can deliver it into through the data warehouse, through the lakehouse, through the mirroring, open mirroring API, which I'll show you a demo shortly. And then, of course, we can deliver that data into things like ADLS, event hubs. And there's different reasons why you'd go with one versus another. For now, the one source that is supported with the open mirroring is SQL Server. So currently, like as of today, if, for example, you wanted to move Oracle, let's say, data into Fabric, you would need to either use, if you were going to use Striim, you would need to write to the warehouse, to the lake house, or to ADLs, or to event hubs. So what that would entail, what that would mean is that there would be some storage costs on the Fabric side because it would not be taking advantage of the mirroring APIs. But our plan is over time to add additional sources to the open mirroring target. But in the meantime, as I said, if you have different sources, you can always reach out to us, and we do have ways of getting that data into Fabric. And then Meraki, maybe we can jump into the demo. I can't hear anything.
In this demo, we will show you how Striim's partnership with Microsoft offers a seamless solution to replicate SQL Server data to Microsoft Fabric. A leading supply chain firm wants to improve visibility and traceability. They plan to centralize data from SQL servers across locations into Microsoft Fabric for real-time analytics and Power BI dashboards. The primary challenge is real-time data streaming from on-premise SQL servers to Microsoft Fabric without disrupting production environments with minimal effort in managing it. This integration leverages Striim's high-speed data ingestion and transformation capabilities with Microsoft Fabric mirroring service for efficient and seamless data mirroring. With a few simple steps, users can build the data pipeline in under 5 minutes to replicate data to Fabric. First, we will search for Striim in the Azure Marketplace and select the SQL to Fabric mirroring solution and subscribe to the standard plan. Striim offers the first month for free. Azure redirects to Striim Cloud. Simply sign up and sign into the SQL to Fabric mirroring service. Next, select the closest region to the SQL server while creating Striim Cloud service. Once service is ready, simply click on the Launch Service. Now we will create a pipeline. This service is purpose-built to replicate an on-premise SQL server to Fabric, and so most of the options are pre-selected for the users. Striim supports 3 types of mirroring: full tables and changes that mirror full tables and incremental changes, snapshot base, which mirrors only selected tables, and finally, incremental changes, which is only mirroring. Next, we will configure the source and targets. For the source SQL Server, make sure you have configured Azure Private Link from your subscription to Striim Cloud. Alternatively, Striim supports SSH VNet peering to the source databases. Select the schemas and tables to mirror from SQL Server. For the target Fabric, we recommend using a public endpoint. You will need to provide the Fabric workspace name and workspace ID with access credentials. Striim automatically chooses smart defaults for batch policy and number of parallel threads for optimal performance. Now let's go to the Fabric UI and make sure tables we selected do not exist on the Fabric OneLake. Striim creates 2 smart data pipelines to track initial load in CDC and coordinates them automatically. In the Microsoft Fabric UI, you can see Striim has created the necessary mirroring pairs for the tables and data being mirrored to Fabric Data Warehouse by mirroring service seamlessly. Next, we will create real-time data insights in the Fabric UI. We will create a supply chain dashboard to track the order's quantity. Let's select the top 10 orders to track in our dashboard. To simulate the real-time experience, we will update the order table to a higher order quantity. Striim catches the update event in real time. Let's take a look in the Striim monitoring dashboard so you can see the report shows the update's details. In Fabric OneLake, Striim writes the incremental changes in Parquet file format. From here, mirroring service automatically reads from OneLake location and mirrors it to the data warehouse. You can see the replication pair reflected the update count. Now let's look at the Power BI dashboard. As you can see, the new order quantity got updated in the chart in real time. Thanks for watching. In this demo, you have seen.
Awesome. Well, we're super excited for our users to start leveraging the amazing open mirroring integration that the Striim team has built. This is a partnership that we really value, and please let us know what additional sources that you'd like to see. That's feedback that we're actively collecting. But this is in public preview and ready for your use. You can find it on Striim's platform, but also in our documentation if you want to learn more. We also encourage you to build your own open mirroring source and tell us about the experience. We're actively growing the program and learning from your use cases to try and build out the best possible APIs we can for open mirroring. So a couple things to end today. I do want to remind you all that mirroring is free storage for all replicas on OneLake. So you can leverage the free 60-day trial of Microsoft Fabric and get started with mirroring today and not have to pay a single dollar for any of the mirroring capabilities. Like I've been indicating kind of throughout the session today, all roads lead to OneLake. Our goal is to help you create a unified place for all of your data, so all your users can be successful with their data engineering, their analytical, their AI, their data science use cases. And we're super excited for all of the amazing innovation that's coming to the open mirroring roadmap, as well as for the amazing work that our partners are doing. If you have questions, I think we can pause now and actually take any questions. So there's one question for the coming soon. Is Oracle the on-premise Oracle DB? That's a really great question. Let me follow up with you on that. We are working on a first-party integration for Oracle, but we also have our Oracle Golden Gate integration that you can leverage today. Happy to share some documentation offline for that. But it's in public preview today, so please go ahead and take it for a spin and let us know what you think. I believe it is for Azure Oracle DB, but let me double check on that and get back to you.
Yeah, and I'll just add to that, Meraki. So Oracle obviously is a source that Striim does support and has supported for a long time. So all the different flavors of Oracle, wherever that Oracle may be, whether it's on premises or on OCI or wherever it may exist. So if that's a need you have for the short term, that's something that we can help you with currently.
Yeah, maybe that's a point of collaboration for us as well with open mirroring. Awesome. Any other questions before we end? Perfect. Thank you all for joining. Really appreciate it, and looking forward to seeing you on the next session.